All right, so this is section 1.3. I want to give some more help on dividing complex numbers, and there's a couple of things we need to talk about before we just jump into it. So the first thing is the idea, right? We need to talk about the concept, make sure you know what we need to be doing. So when you're dividing these complex numbers, really you're just trying to simplify this. And in math, when simplifying, right, there's a couple things you got to know, or there's plenty of things you got to know, but here's something specific to our situation. The answer is not simplified if you have a square root in the denominator. So it's not fully simplified if square root in denominator, right? All right, that's not fully simplified. And, well, what about an I? Well, remember that an I is equal to the square root of -1. So if there's an I in the denominator, then it's not fully simplified. So how do we simplify these, right? Well, there's the concepts of I is how you're going to think about it. So, well, what can I do to make the I, because I need to think about it as square root of -1, right? Well, how do I get rid of the square root of -1? Well, what if I said this right here squared, right? If it was I squared, then the square root of -1, the square root and the square, right? That kind of cancels each other out, and you just have -1. So that's one way, but it's not always that simple. So let's talk about it. Let's work through these two examples. All right, so I'm gonna start with 79, and these are right from your notes. They're like extra problems that I put in your notes. So number 79. Now, I want to get the square root out of the denominator. I want to get the I out of the denominator in order to say this is fully simplified. Well, remember, I equals the square root of -1. If I want to make the square root go away, that's how I simplify it, then I need to get the I to be squared, right? Because if that's squared, right, that thing's squared, then it cancels out and it just equals -1. So what can I do? Well, when you're talking about expressions, right, that's what these are, expressions, because there's no equal signs anywhere, so they're considered to be expressions, not equations. When you're messing with expressions, there's not sides, right? There's, in this case, there's a numerator and a denominator. Now, some people say, okay, well, if you square the numerator, you square the denominator. Well, that doesn't hold up if you think about an example like, okay, what about 4/5? If I change the numerator and the denominator, they should always be equal to the same thing, right? But if I square the numerator, that's 16, and then I square the denominator, that's 25. That's not the same thing as 4/5, right? But if I'm trying to get the denominator squared and I multiply the numerator and the denominator by 5, well, then you got 20/25, and that is the same thing as 4/5. That, right? It still simplifies. So the answer is not squaring, the answer is multiplying, but we want it to be squared. So if I multiply the denominator by I and the numerator by I, then I'm really just multiplying by I over I, which is 1. You can multiply anything by 1 and it stays the same. So then this becomes -5I over I squared. And we know I squared is -1, so this is -5I divided by -1. So that becomes +5I, right? And that's your answer. Simple as that. Now, what about when it's not so simple? What about when it looks like that? Well, this is when we got to take into consideration what's called complex conjugates. And we're going to talk about this in class. At this point, we haven't talked about it yet, but I'm going to throw this out there for you. So let me just, I guess I can show you with the denominator so it makes sense. So if I take this denominator, 2 minus I, and I want to multiply it by something to make the I just go away completely, right? I can't just multiply it by I, because if I do that, then I have 2I times I squared, or I'm sorry, 2I minus I squared. And although this I goes away and it becomes -1, now I got a new I, right? So that's not the answer, just multiplying by I. That's usually what people say to begin with, but that's not the answer. Instead, you use this concept of conjugates, right? And you've seen this many times before in Math 3, right? We've all seen this thing. And it says that if you have, a squared minus b squared, we can factor that into a plus b times a minus b, right? This is the difference of squares. Hopefully you've seen that many times. You should have seen it in Math 1 and Math 2 and in Math 3. And if you've taken Math 4, you've probably seen it there too. And we can, like normally we see this and then we factor it into that. But we can also use that in a new direction. We can take, we can take this and make it into that. So let me show you what I'm getting at. So what I want here is to make this I go away. Well, if I multiply this by 2 minus I, right, or 2 plus I, sorry, 2 plus I, then that's going to equal, just like, let me write it, A minus B times A plus B is going to equal A squared minus B squared, right? Difference of squares. We'll look at it here. This would be 2 squared minus I squared. Now the I is squared, right? Without the 2 being multiplied by I. So this is what? This is just 4 minus -1, which is in turn 5. Right? So that's the secret here. That's how you got to handle this problem. So we'll do it again. I'm going to erase this stuff and then we'll do it again so you can see it in action, right? Where's my pen at? All right, change to green. So, like I said, I need to get this stuff out of the denominator. So what do? I multiply the denominator by 2 plus I. And then I also multiply the numerator by 2 plus I, because as long as I'm multiplying it by 1, it's fine, right? An expression, as long as you're multiplying it by 1, you can do that, and you won't have no problems. And 1 is anything divided by itself, so if I'm multiplying it by 2 plus I over 2 plus I, it's all good, right? So this becomes, I'm going to write it in parentheses, -3 plus 4I times 2 plus I divided by 2 minus I times 2 plus I, right? Now the denominator, like we just said, is 5, but I'll show you again because you can work it out the long way in box method, which is how I work out the numerator. But in the denominator, you might as well just use the difference of squares, right? That's 2 squared minus I squared. 2 squared is 4 minus -1, which gives you 5. Now, you don't have to take that. That's the easiest way to do it, though. Why wouldn't you? All right, so the denominator is going to equal 5. But let's do the numerator. I'll do it in this yellow and see what happens there. So for the numerator, I'm going to use the box method, which you should use some method other than just doing it in your head, And then 2 plus I. Alright, so box method just means we multiply where the intersection is. So -3 times 2 is -6. 2 times 4I is 8I. Right? I times -3 is -3I. And then I times 4I is 4I squared, right? We got to remember that I squared is -1, so this is 4 times -1, which is just -4. And then we can, condense this, which -6 and -4 make -10. And then -3I and +8I make +5I. So that means that here's what we got going, right? We got negative 10 plus 5i is the numerator, and the denominator is 5. Now we can simplify that a little bit further, because 5 goes into 10, or 10 divided by 5, I should say. 10 divided by 5 is 2, so this becomes negative 2, and then 5 divided by 5 is just 1, so this is negative 2 plus I, and that would be your answer. All right, hopefully that was helpful to you.